Hello, everyone. I would like to talk about section 3.1, formula mass and the mole concept. We are actually going to divide this into two videos because these are important concepts and I want to have the time to focus on each. So in this video, we will be looking at formula mass. So the learning objective for this video would then be calculate formula masses for covalent and ionic compounds. So let's go ahead and get started. So formula mass is basically finding the average atomic mass of a compound, similar to how you would have done for an element by looking on the periodic table. The difference here, of course, is that in a compound you have more than one element, so we need to know how to basically add all of those things together. We're kind of separating this into, we already talked about the distinction between covalent and ionic compounds. So we're going to go ahead and continue with that here. And hopefully as we go through, you'll see why we are doing that, even though the actual calculation is very similar to be almost identical for these. So if we have a covalent substance, we can refer to the formula mass as a molecular mass. And that is because we are looking at the mass of a molecule, so we can use that term, which is not true for ionic compounds. So that's why we make that distinction. How we do this is we look at the formula. So here in this example we have chloroform. You don't have to know that this is the name chloroform goes with this formula CHCl3. So what we would have to know to do is find the periodic table and look up each of those elements on the periodic table. So from the formula, we have C, we have H, and we have Cl. So part of that is recognizing, okay, that's three different things. And then how many do we have? We have one of this, three of this. And then what we do at that point is look up the average atomic mass from the periodic table. So again, that is the number below the symbol of the element. So I went ahead and pulled up our periodic table from our textbook just to remind you how we find these numbers. So we had carbon, so we find C. Underneath that we have 12.01, so we would write down that number. We have H. Underneath that, we have 1.008, so we would write down that number. And we have Cl, so we have 35.45, so we would write down that number. So this is how we find the average atomic masses from the periodic table. Okay, so going back to our calculation, we're showing those numbers here. I want to mention something. Actually, let's go back here. So this is the periodic table from your textbook. You may have a periodic table from another source that has, maybe more significant figures than what we're showing here. These often go out to, say, 4 or 5 digits. It is okay to use more than that. But what I would say, and let's go back to this table to kind of emphasize this, you want to go to at least 2 decimal points here. So instead of carbon just saying 12, we want to go ahead and say 12.01. Technically, it is better for hydrogen to go to 4, 1.008. And in some cases, that will make a difference, but most of the time it doesn't make too much of a difference. So I would be fine if you call this 1.008. I would also be fine if you called it 1.01. So either of those is fine, but you don't want to just stop at 1. You want to go ahead and include those significant figures. And the reason is, if you think about if you're later doing a calculation with this, You don't want the periodic table to be the thing that's limiting your significant figures. So if we go out to 2 decimal points, that's typically sufficient for what we're dealing with. And then we have the chlorine. So what we do is we multiply each of these by however many we have in the formula. So we have CHCl3. 3 is the only number that's showing up there. But if we don't have a number, it's assumed to be a 1, right? So we have 1 carbon, 1 hydrogen, and 3 chlorines. So we multiply the average mass for each of the elements by the number of elements in that formula, and we get these subtotals, and then we add them all together to get the formula mass. And again, because we're doing this for a molecule, we can call this a molecular mass. The units here again are AMUs, which are the units we use for atoms on the periodic table. So that's how we go about finding formula mass. Here is a more involved example. I'm not going to go through this in detail, but you can see that kind of the same thing. We have the subscripts are telling us how many we have of each of these different atoms, or how many atoms we have of each of these elements, and we're multiplying whatever that number is by the number we look up from the periodic table to get the subtotals, and then we add the whole thing together. I would recommend, if this doesn't seem completely straightforward to you, to go ahead and do this example. So they're giving you the formula. Don't look to the solution yet. Go ahead and set this up in a way similar to the way this one was done. Solve for it, and then look at the answer to check your work. So I'm going to skip past that, so you can have the space to do that example on your own. Let's also talk about the formula mass for ionic compounds. So here we're showing an example for sodium chloride. And if you look at the table, the calculation looks almost exactly the same as what we had done before. And it essentially is, right? We're looking at, okay, we have this formula, and we use that. We look up the elements, add them together. In this case, it's a 1-to-1. What is different is what the formula mass actually means. So again, for an ionic compound, we're showing, okay, this is an ongoing crystal lattice structure. We don't have exactly 1 sodium and 1 chloride ion, but we have this formula mass based on whatever the simplest formula is, which is NaCl. So technically, the only real difference here is that we shouldn't use the term molecular mass for ionic compounds. That should be reserved for molecules, so for covalent compounds. And we would use the term formula mass more specifically for ionic compounds. As it turns out, in the second section, or second part of this section, we'll see there's another term that's more universal and more applicable to pretty much everything we'll be using. But I'm going to wait for that second part before introducing that to you. So that's the first part on calculating a formula mass. So make sure this is something you understand before we move on to the second section of this, or I should say second part of this section, because it's a concept that will continue to build as we look at that part.